Hello, today we are going to look at simplifying algebraic fractions. So we already know how to simplify fractions. We would look for the highest common factor top and bottom and divide it out. So if we had something like 12 divided by 9, how would we simplify that fraction? Well, we would look for the highest common factor of both of these numbers. What's the highest common factor of 12 and 9? It is going to be 3. So I would take out that common factor, 3 divided by 3. And now what do I have? Well, I effectively have the fraction 3 divided by 3 multiplied by 4 divided by 3. And the core argument of all of this simplification is going to be any number divided by itself gives me 1. So this fraction simplifies to 1, and I'm just left with 4 over 3. This is the core of everything we are about to do. And even though it will look more complicated in algebra, the core idea is exactly the same. Find the highest common factor of the top line and the bottom line, factorize them out, and see if there's anything common to the top and the bottom that allows us to divide it out to 1. Again, any number, no matter how strange it looks or how many letters it has in it, will always divide out to 1 if you divide it by itself. So let's look at this in practice with our first example. So what am I going to do? I'm going to look for the highest common factor on my top line and then see if there's any common factor to it on the bottom line. So my highest common factor of my numbers on the top line is going to be 2. My highest common factor of the letters on the top line is going to be x, and I end up with 3x minus 2, and then that's over 12xy. Now I've factorized this. Is there any common factor that I can get top and bottom? Well, there is. 2 and 12 have a common factor of 2, and I have a common factor of x top and bottom, and y is not a common factor top and bottom. So let's rewrite that, 2x. So my top line is unchanged. I've already factorized it. Can I factorize my bottom line now to get common factors out? 2x is common here. So I have 12, so that would be 6x I've taken out as my common factor, and y. I now have 2x divided by 2x. I can do this because everything on the top line is multiplied by 2x and everything on the bottom of the line is multiplied by 2x. If there was addition, if there was a plus sign in here, I would not be able to divide top and bottom. I can only do this when I could break this up into one fraction multiplied by another. So, for the sake of the moment it takes, let's write that out explicitly. I have the fraction 2x divided by 2x all over 3x minus 2 all over 6y. And this fraction divides out to 1. And I end up with 3x minus 2 all over 6y. The core of the argument is if I have stuff multiplied on the top and the bottom, I'm able to break this effectively up into two separate fractions multiplied together, and 2x divided by 2x is 1, and I'm just left with the non-common stuff. Now this type of question will often be mixed in with other types of factorization we've done. So far we've looked at common factors, just straightforward common factors, which is what we always try to do first. As we know, often other types of factorizing will be mixed in. Here, what do I recognize this top line as? Well, I see something squared and then a minus, and I know that 25 is a perfect square. It's 5 squared. So this looks like dots to me, difference of two squares. On the bottom line, is there any factorizing I can see? Well, I can see that I've got 2a plus 10. I can see there's a common factor of 2 on the bottom line. So let's try and factorize that bottom line and that top line. So I need to write this in the form of difference of two squares. So my top line, I have a squared minus 5 squared. That's now in dots form, difference of two squares form. And I have 2a plus 10, and I can see a common factor there of 2. So when I take that out, I end up with 2 times a plus 5. Now I apply dots, difference of two squares, and I end up with a plus 5 multiplied by a minus 5. Don't know why I wrote 6. 5 on 2 on a plus 5. Can I see any common factor top and bottom? Well, I can see this whole bracket here. This whole bracket here. A plus 5 is multiplied by everything on the top line, and a plus 5 is multiplied by everything on the bottom line. So I can write that out as a separate fraction. A plus 5 all over a plus 5. Just rearranging my multiply. Remember, 3 by 2 would give me 6, and 2 by 3 would give me 6. So I can swap what is in front for multiply, and it won't make any difference. So minus a minus 5 all over 2. Now I have a plus 5 divided by a plus 5. Now, even though this looks like a more complicated thing than when I had 3 divided by 3, it's actually logically the same. Whatever a is, I have this number, a plus 5, whatever a is, plus 5 it will just be a number. So I have a number divided by itself. So even though it looks funny, I'm able to just divide that out. That's 1, and I'm left with a minus 5 all over 2. We can also get situations where we have things like trinomials. We have our quadratic trinomials, and we're going to have to do out our factorization. Now, unlike difference of two squares, which we can follow reasonably nicely from line to line, this requires quite a few steps. So this we're going to have to take out a bit of our sum and be careful we don't forget about the rest of it. We're going to take out the top part and deal with it, factorize it, and then put it back into the original question, because otherwise it just gets too messy. So we go down through our different steps for our factorizing our quadratic. We have x squared and then x and then number. There's no common factor that we can see on the top line. So what are we going to do? We are going to factorize out. We're going to multiply the coefficient of x squared by the constant on the end, and we are going to get minus 8. And again, the sign matters. The fact that this is a minus 4 we have to take into account. So 2 multiplied by minus 4 gives me minus 8. And I write out all my factor pairs of minus 8. And then I see which one of these is going to give me what I want. Which one is going to give me plus 7 when I add them together. Well, that's going to give me minus 7. That's going to give me minus 2. That's going to give me plus 7. So minus 1 plus 8 is going to give me what I'm looking for. That's going to give me the number in front of my x, the coefficient of x. So then I break up my quadratic trinomial into my 7 in my quadratic trinomial into minus 1x plus 8x minus 4. Look for my common factors for my first two and my second two, being careful that my signs work out. X on 2x minus 1. X divides into minus x minus 1 times. And then we have a common factor of plus 4 here. And then we have 2x minus 1. Sorry, we have our bracket is common to both. So we write down our common factor of the bracket on x plus 4. And now we have this business here all nicely factorized. So let's write it back into our original question. So we have 2x minus 1 on x plus 4 all over 1 minus 2x. Can I see any common factor top and bottom? Almost. I can see that I have a plus 1 and a minus 2x here, and that is multiplied by everything on the bottom line, and I have a 2x minus 1. That's very close to being the same thing, but it's not quite. So what's wrong? Well, what's wrong is that I have a signs the wrong way around. So what could I do when I've been doing my factorizing before? What could I do to change my signs around? Well, if I take out a common factor of -1 to the stuff here, so if I take out, sure, I like those equal signs there. So if I take out a -1 on the bottom line, I'll have -1. -1 divided into +1 will give me -1, and -1 divided into -2x will give me +2x. And now I have +2x minus 1 multiplied by everything on the bottom line and multiplied by everything on the top line. So I can write that as 2x minus 1 divided by, if you like, -1 plus 2x. Remember, that will be exactly the same thing. Multiplied by the fraction x plus 4 all over -1, which would give me x plus 4 divided by -1, which by convention we tend to try and avoid having minus signs on the bottom line, so we divide that into both things on top, and we'd end up with -x minus 4. So let's do our final step here. Here I can see I have a quadratic trinomial, and I have something that looks like difference of two squares, something squared and then a minus. So I need to take out my, just like I did last time, I need to take out my quadratic trinomial because it's too messy to try and deal with in the middle of the fraction, and I'm going to factorize that out. Now when I've written out all of my factor pairs for my coefficients multiplied together, which one is going to add to give, there's a plus x. So what does that mean? It means there's a plus 1x. So if I look through my list, -5 plus 6 would give me +1. That's going to give me my hidden 1 in front of my x. So I factorize out that way. 3x squared minus 5x plus 6x minus 10. And I see what I can factorize there. So I just have x that I can factorize out here. 3x minus 5. And I have, and I take out a common factor of 2 here. And I have 3x minus 5. So I end up with 3x minus 5 on x plus 2. Again, I have a common factor of this whole bracket, a common factor of this whole bracket. Now I have this factorized, I can bring it back to my original situation. I have 3x minus 5. I'll write it out. Now can I factorize my bottom line to get anything that's going to work out as a nice common factor here? So 3x minus 5. I recognize that this is dots because I have a squared thing and then a minus, and I can see that 4 is a perfect square. I don't have to worry about common factors. There's no obvious ones here. And I'll write it out. Now that I've done dots, do I have anything that I can see as a obvious common factor top and bottom? I can see I have x plus 2 multiplied by everything on the top line, x plus 2 multiplied by everything on the bottom line. So this whole fraction, this whole bracket, I should say, is my common factor top and bottom. So let's write that out as a separate fraction. And when I do that, again, I have the bracket multiplied by everything on the top line, bracket multiplied by everything on the bottom line. This only works for when everything is multiplied together. It does not work if these things were added together, because we can't take them out as factors. Factors have to be multiplied together. So when they are multiplied together, I can write them out as a separate fraction, and x plus 2 divides into x plus 2, and I'm left with 1 here, and I just have 1 multiplied by 3x